In this video, we're going to be talking about two types of reasoning. These types of reasoning help us come up with logical conclusions, but they help us a lot in math, especially in geometry. They come in two types. There are what's called deductive and inductive reasoning, and there's a big difference between the two. Deductive reasoning is where you start with your conclusion. You start with a known truth, and then you back that up with more statements or more known truths until you reach a valid or logical conclusion. For example, it is known that all squares have four sides. So if I draw a square, then I know that what I drew has four sides. It's impossible to have drawn a square without drawing four sides. So we start with a known universal truth, and then we can back it up with more truths until we come to a logical conclusion. The important thing about deductive reasoning is that it's not possible for our conclusion to be false. It is impossible for me to draw a square without four sides. Here's an example where I could do the same example, but I could use deductive reasoning incorrectly. We start with our same initial statement. All squares have four sides. I draw a shape with four sides. Does that necessarily mean that I drew a square? If I come up with that conclusion is false, or it may be false. And that is not a good use of deductive reasoning. I cannot come up with a false conclusion. So what's wrong with that example? Well, there are many shapes, some specifically that have names, some that don't, that have four sides. Any four-sided shape is called a quadrilateral. There are specific types such as trapezoids, rectangles, rhombi, a lot of different types. So just because I drew a shape with four sides does not mean that I drew a square specifically. So again, deductive reasoning cannot have a false statement or a false conclusion. One more time, let's do it correctly. This is a pretty famous one. All humans are mortal. I'm a human. Therefore, I am mortal. The first statement is a true statement. All humans are mortal. The second statement is true. I'm human. And my conclusion is valid. There's no other conclusion I can come up with. If I'm human, I have to be mortal. Let's see how inductive reasoning is different. Inductive reasoning is where we kind of go backwards. We start with our observable patterns or repeated experiences in life to draw conclusions. And it is possible that that conclusion may end up being false. So the conclusions that we reach by inductive reasoning are sometimes called a conjecture, and a lot of times in science classes they'll be called a hypothesis. So we know that that may not be true. We are going to try and prove it, but again, it may be false. So for the first example, De La Salle is a Catholic high school. That's a true statement. I'm Mr. Ritter and I teach at De La Salle. That's also a true statement. Here is where it starts to get a little sketchy. If I conclude that therefore I am Catholic or Mr. Ritter is Catholic, that would be a false conclusion. So even though we started with two true statements, our conclusion is false. Let's try another one. This morning I observed that the grass is wet. That's true, I see it, it's wet. I know that rain makes the grass wet. That's also true. Is it a good conclusion to say, or a logical conclusion to say, that the grass is wet because it rained last night? Possibly, but I would need more validation. It is possible that the sprinklers were on, or that a dog was walking by and had to go to the bathroom. So we can't for surely, based on these statements, say that it rained last night and that is why the grass is wet. We could investigate and do more deductive reasoning. I could find a weather report and I could add that to my proof, and then my conclusion might be a little bit more logical or more valid. So the big difference here is that deductive reasoning cannot have a false conclusion because it is always based on facts or true statements. Inductive reasoning is based on patterns that you observe or experiences that you've had, and that leads you to a possible conclusion, but it may be a false conclusion. Many superstitions and stereotypes are the result of inductive reasoning. You could think if you're an athlete and for the last several games you've been winning and you've been wearing blue socks, you might conclude that if you wear blue socks, you're going to win the next game. It may not be true, though, but it may make you feel more confident and lead you to winning more games. So it may seem that deductive arguments are stronger and inductive arguments are weaker, but that's not necessarily how we need to look at it. What we need to look at is how they influence each other. If I don't know something, I want to come up with a hypothesis. I want to come up with that statement that I want to test, and that's using induction or inductive reasoning. If I test it and it's true, then I can start deducing or coming up with a deductive argument. If it's false, though, I swing back around and I start to ask more questions or I start to make more predictions using inductive reasoning. So they influence each other, and this is how a lot of scientists go about their life. Constantly trying to prove something, somebody else disproves it, they got to go back and prove it. And it's a healthy relationship. It's something that should happen. Let's do a little bit of math today, and let's practice using this idea of inductive reasoning to find the next terms in a sequence of numbers. We're looking for patterns, so we're looking for using inductive reasoning. Let's consider the sequence. Can we find a pattern in these numbers? Well, if I go from 10 to 7, I'm subtracting 3. From 7 to 9, I'm adding 2. From 9 to 6, I'm subtracting 3. From 6 to 8, I'm adding 2. 8 to 5, I'm subtracting 3. 5 to 7, I'm adding 2. It seems like the pattern is subtract 3 for the next term, then add 2 for the following term. So if we use that pattern, if I subtract 3 from 7, I get 4. If I add 2 to 4, I get 6. If I subtract 3 from 6, I get 3. And if I add 2 to 3, I get 5. Let's do one with fractions, a little bit harder. Can we find the pattern between these fractions? If I'm going from an eighth to a fourth, I know that I am getting bigger. So I could be multiplying it or I could be adding. Let's try and get common denominators here so we can compare them. A fourth is the same as 2/8. So I go 1/8, 2/8, 3/8. A half is 4/8. So it seems like I'm adding an eighth every time. So that would change my pattern here. There we go. We're adding 1/8. And if I do that, if I continue it, remember a half was 4/8. So if I add an eighth, I get 5/8. If I add another eighth, I get 6/8, which reduces to 3/4. If I add another eighth, I get 7/8. So again, these patterns, these answers, they seem to hold up. But again, we're using inductive reasoning. It could be possible that if we continued this sequence, we would find that our pattern didn't hold up and we would have to try again. But these seem to be good. All right, so good luck using inductive reasoning and finding the next terms in a sequence.